Assalamu alaikum. Now we continue range kata method for solving initial value problem. Last time we talked about improved Euler method, which is called also range kata method. For simplicity, we would like to use Butcher matrix. So this is called Butcher matrix. That one will be written like, because we have here a half times K1. So we'll put a half here. And here another half times K2, we'll put a half here. And then we will write here, this one here, K2, here is 1, and here is 1. I'll explain this later on, so this is 1, this is 1. The others are 0, because this is just, we are not talking about other matrices. So this is called Butcher matrices, can be full matrix, but we take this matrix is easy to obtain explicit range kata method. We don't want implicit because implicit is more difficult. So in general, this one called range kata methods. And in general, let me write it down. So here can be written this way here, which is always the first one 0. So another constant, C2, C3, C4 continue. And here, second column, like here A. So this one here A, so it means A21, A31, A41 from matrix, and this one here A32. If you continue here now, this row O41, O42, O4, and so on. And here we can take W1, W2, W3, W4. So we'll stop. If we want to continue for higher stage, it means we here have 5. So it's always here. Above is not written because all of them are 0. So this is really called range kata. And we are lucky here in this university because Butcher visit us here and talk about his matrices just about a few years ago. So in that case here, we will talk about it. Okay, to be range kata, there should be certain properties. What are they? Well, this one here, if I want to write it just in very small things, it will be like this here, just like this, and here is A, the matrix, and here column C, and here W transpose column. So this is a very short way to write it down. So here we are now. So now what are the properties? Always the summation of the right hand side equal left hand side. So here summation of this one here, because it's only one, so this should be equal to this. That was written here. Now next steps, this plus this should equal this, which means C3 should equal this right hand side. Next law, again summation of this one should equal this, and continue in this way. Maybe for big matrix as well. Well, some books don't write the equal here one. They don't write this one here. But I prefer to write it. It means here the order is 1. Summation, if the summation of this one equal to 1, it means we write it 1 here, which means the order is 1, which we will learn about it later on. This is called in general form of range kata methods. So, and one of the example, as I said here, well, here is the example here of improved Euler method can be written like this. So, and now we'll go to next slide to see how we learn about it. So here is the general form. What in general yn plus 1 equal yn, and here now WK1 plus W plus, but here this should be times H here, so it is okay now, no problem. But so this one here continue on like this. So if we take this example, just let's take some example to understand. So if we have this one, well, here summation a half equal a half, 0 equals 0, and this one here. So how can you write it down? Well, just here y equal 0 times K1, it's no K1, and then 1 times K2, it means this is the Y1. So this is given here. And then K1 always HF, XN, YN, because it's here, always like this. No mistake at all. But this one we have to be careful now. This number here is written here coefficient of h, which means xn plus half of h, and the other here, this 1/2 is here times k1. So in that case here, this method is defined. If we write it this way now, different way now, again it is, so here, look at this number here, it's written here. 1/4 times k1, 3/4 k2, where k1 as before. K2 is this number times h, and this number here times k1. So in that case here, this method will called for some reason optimal method. This called midpoint methods. You don't need to memorize this one now. Okay. Again, another method here. What is it here, this one? Again, look here, 1/2 and 1/2, it means here. This one always the same, comes from here. And that one is like this. What is it here, this one? Well, we already have it. It's trapezoidal method, so which we know before. So if we take for another example now, suppose it's like this. Again, look at the bottom here. It's equal this. And this one here, this is always the same. And this one here, 1/2. And the other 1/2. But look at this one here, 1. So this one here, 1 times h. Minus 1, it's written here minus k1. Here 2 plus 2k2. And here this called Ranjkata or RK of order 3. Why it's order 3? We can prove it later on. Another one here, this is the famous one, which called Ranjkata of order 4 or RK of order 4. This famous one, and it can be written easily. Look at this number, we wrote them here. W1, it means 1/6 plus 1/3 plus 1/3 plus 1/6. So here is it. K1 as before, the same. And this one here, 1/2 comes from here. And the other 1/2 is putting here. H, K1. Here remain H, but here be careful. K1, K2, K3, and so on. Here but remain H all the time. So this 1/2, H is here. 1 is H is here. The right hand side 0, no K1, it means 1/2 K1, this is 1/2 K2 now. And 0, no K1, no K2, there is 1 times K3, this times K1. So this one called the famous one, sometimes they call it only Ranjkata method. When they say Ranjkata method, they mean this one, which is the famous, popular Ranjkata method of order 4. So this is the idea. Just now we have to move just to see how to apply this one. Okay, I'll start with the long one. The famous one here was apply RK4 to this problem. And this is order 4. It means the error really much smaller than the others. So here said as before, H equal 1/2. How to write this one here? Just we already wrote it before. Just rewrite it again like here. So we have to start with this one. So it says here, define what is f of n. This is called f of n. It should be really written like this here. It is easier if we write it f n equal 2 xn yn. So instead, like from here, and we know the step length, we know these values. Substitute now k1 here, we put, of course, n is 0 now. We obtain this one here, we got it 0. We calculated several times. Now what is k2 here? Just it's written from here, but xn is 0 now here. So we write it here 0, and here h 1/2 is like this, and y0 is given 1, and this is times k1, which already found here, so it goes here. Just here calculate, this is mean the function value should be calculated at this value, x, and y is this. Substitute, it means we obtain this one here, the answer. We found k1, sorry, k2. Now K3, again, x0 plus 1/2 h, I know 1/2 h, so substitute it. Y0 plus K2, I know K2, that's explicit. So here we know the answer. When you calculate this here, it means you have to calculate the function x for this 1 over 4, y equal this, and we calculate this one, you get this answer. Now we know K3, we move on to K4. It is long, but assume you are putting in the computer, it's very fast, so no problem. So think about computer and please put it to solve some problems in the futures. So this one here, again, h is a half, and here we calculate this 0 plus h, and here y0 plus k3, which we found here, so we put it here. We always here put it here, and so on. Substitute means x, we have to subtract a half, and this is y. 4 decimal places is enough, so when we substitute here, we get this answer. Now I know K1, K2, K3, K4, so now we know how to calculate this one. Just substitute in that case, and we obtain this one. So we know now Y1, like this, and we found the answer. Now, repeat again, but for n equal 1, repeat for K1 equal this one here is the value, substitute, this is Y1, this is here F, and we got this answer. Take this answer to calculate K2, find the answer. Take this to calculate K3, always explicit. Okay, take this answer, so it means we cannot calculate this before this, should be in order. And now we know all K values of K, so we calculate, we found the answer. And when you put it, here is the answer here. Find the error, this is the smallest error we found until now. Even h is a half, all the previous method give me high order. If you use 0.2, it will be much smaller than this one. So here, it is really long, but the order is high, as we may prove it later on. And this one here, so it means we will talk about the order of the method next slide, and I'll stop here. Thank you very much.